Hey, Algebra 2. We are having just a practice week. Okay, you learned a lot of new material. You learned 3 different ways to factor, taking out the greatest common factor, difference of two squares, and trinomials. So I know this is a lot of practice. I'm going to go through several with you so you have some examples. Okay, let's start. Get your 5-2 practice out. The one that starts x squared plus 4x minus 21. It's the very first page, and we're going to go to number 5. Okay, I just want you to have some that are worked out. Okay, first thing I want you to notice is that it is a trinomial. 1, 2, 3 terms. It's not going to be the difference of two squares, okay, because there are 3 terms. So the first thing you should do would be to set up your parentheses. It's going to be a binomial times a binomial, okay? The only 2 things that multiply to x squared are x and x. It's kind of nice whenever there's no number in front of the x squared, because then you know it's going to be x and x, okay? Since my last term is negative, I know I'm going to have different signs. One's going to be a plus, one's going to be minus. That's the only way to get a negative 12 is when I multiply 2 things together. Okay? Then I think maybe it's 6 and 2. Okay? Because then my outer product is 2x. 6x is my inner product. How can 2x and 6x add or subtract to get negative 1? That's what I need, a negative 1 in the middle. 6 minus 2 is 4. 6 plus 2 is 8. That's not working out. Okay, good try, but 6 and 2 are wrong. What else multiplies to 12? Maybe 4 times 3. I tried 6 and 2. Oh, now my outer product is 3x. My inner product is 4x. 4 minus 3 will give me 1. Now I need it to be a negative 1. So I need it to be negative 4 and a positive 3. That's what will combine to give me a negative 1. It's just a puzzle. It's just a fun puzzle with numbers. If you like to do Sudoku or any of that, this is another type of puzzle. I do a quick FOIL. Okay, x times x is x squared plus 3x minus 4x. That gives me the negative 1x in the middle. And yes, negative 4 times positive 3 is negative 12. Done. Okay, let's go on to number 15. If you'll just move down a few columns for me. Let's look at what's different with 15. 15 doesn't have 1, 2, 3 terms. It only has 2 terms. And it's a difference, right? These are the kind we love. I do anyway. When I see 2 terms in a subtraction, I'm hoping I'm going to still do the same thing. I'm going to have 2 binomials multiplied together. And I'm just thinking, what's the square root of x squared? That's x. What's the square root of 25? That's 5. We're going to write it down once with a plus and once with a minus. If I FOIL that, I get x squared minus 5x plus 5x. That's 0 x's. That's why there are just 2 terms. The x's cancel. And then 5 times negative 5 is negative 25. Now let's scooch down a couple more columns, okay, to, I think I wanted to do number 23. Here's what's different, guys. Be careful. We had this issue on the Schoology assignment that we did last week. We're solving now. Notice now it says equals 0. The other directions were factor. Now it's solve. Okay, so let's look at number 23. I still want to factor to be able to solve. Okay, so I'm going to rewrite my trinomial in factored form. I'm thinking what multiplies to x squared. Again, I have x and x. Not a big deal there. 12 again. Gee, I must love 12. I try 6 and 2. That doesn't work. Sorry, I didn't realize I picked a 12 again. 4 times 3, since the last sign is positive, I know that my signs inside are going to be the same. they're either both going to be positive or both negative. Well, they're both going to be positive because the middle term's positive. This gives me x squared plus 3x plus 4x. 3 plus 4 is 7x plus 12. The beauty of having it in factored form is now I have two things that I'm saying multiply together to equal 0. The only way that can happen is if either x plus 4 equals 0 or if x plus 3 equals 0. And I have two little problems I have to solve that are pretty quick. To get the x by itself, I think most of you remember you subtract 4 from each side. 0 minus 4 is negative 4. Or on this side, I would subtract 3 from each side. X equals negative 3. Okay, so those are the two answers. We actually go the whole way, solve it. We don't just stop here with the factored form. This is set equal to 0, so we continue. Okay? The answers are negative 4 or negative 3. If I put negative 4 in for x, negative 4 squared is negative 4 squared is 16. Plus 7 times negative 4 is negative 28. 16 plus negative 28 is negative 12. Plus 12 is 0. That's what we're saying. When we put negative 4 back in here, I get 0. When I put negative 3 in here, I get positive 9. Plus negative 21, that's negative 12. Plus 12 is 0. Okay? So now you have one kind of each type to have you model that, and I want you to finish that first page, okay? And get that. Next time I see you in class, we'll be looking at these. Let's flip over to the next page where we're still solving, I think. Go up to 25, yeah. I want you to look at number 28. Uh-oh, I don't have equals 0. That's okay, guys. What we're going to do is always make it equal 0. Okay, I'm going to set up these last three, 28, 29, and 30. I'm going to subtract 48 over here so that I have 3x squared minus 48 equals 0. Okay, I want it to look like all the rest. I can't do this if it's not set equal to 0 because that's how I can set the two products equal to 0, okay? This is a special one. I have to, those aren't the difference of two squares, right? 48 isn't, 49 is 7 times 7, but 48 isn't a perfect square, and I only have the two terms. In some of these, you're going to have to factor out a greatest common factor first, okay? So I do notice that 3 goes into 3, and 3 goes into 48. Okay, this is still 3x squared minus 48. If I would take the 3 through, I get 3x squared minus 48. Notice I have the difference of two squares now, right? This part is x minus 4x plus 4. I still have the 3. And I also have x minus 4x plus 4. Okay? Now I set each thing equal to 0. But I noticed that 3 can't equal 0. 3 doesn't have an x with it. So I just set x minus 4 either equals 0 or x plus 4 equals 0. So adding 4 to both sides, I get x equals 4. Subtracting 4 from each side, I get x equals negative 4. Those are my two answers. Okay? This one, number 29, I can't have that negative 10 over there. I'm going to add 10 to both sides. I get x squared minus 7x plus 6 equals 0. Keep going. This problem's not done. I'm just setting it up so that it looks like the other ones, equals 0, equals 0, equals 0. This was equals negative 10. Can't do it. So I added 10 to both sides. Negative 10 plus 10 is 0. Negative 4 plus 10 is positive 6. Now you're ready to solve it, just like you did these others. Okay? I'm not done. You need to factor this and continue. okay? Number 30, I want that to be equal to 0, and I want my x squared to be positive. So I'm going to subtract 9x to the other side. And I'm going to add that 8 to the other side. Now I have 0 equals x squared minus 9x plus 8. And I can continue with that. I have to have it set equal to 0. Again, this is not finished. Okay, you're not done. I need to now factor this. Thinking what multiplies to 8 and we'll add to 9. 4 times 2, no. 4 and 2 is 6. 8 times 1, ooh, that might do it. Okay. All right, then we move forward to number 33. Number 33 is saying find the zeros of the function by rewriting the function in intercept form. Fancy way of saying factor. Okay, we're just factoring. So I am going to rewrite number 33 as x, multiply to 35. The only thing I think is 7 times 5. Oh, that'll work, right? Because 7 minus 5 will give me the 2. The 7 will have to, oops, I forgot my x. The 7 will have to be negative and the 5 positive. Now, we were supposed to find the zeros. In other words, find the x-intercepts. Well, it's in intercept form now. The x-intercepts are 7 and negative 5, right? 7 and negative 5. The reason is because that's where each of these will equal 0. They said find the zeros. So really we're doing the same thing over here. Whoopsies, sorry. We're doing the same thing over here. I'll add 7 and get x equals 7. Subtract 5 and get x equals negative 5. 7 and negative 5. And we knew that from back when we did graphing. Number 36. 2 terms, not the difference of 2 squares. The only thing I have left is to hopefully factor a greatest common factor out. I can take an x out of that, right? They both have an x. So now if I want to see where that equals 0, I set x equals 0 or x minus 6 equals 0. Well, x equals 0 is done. Add 6, we get x equals 6. Okay? So hopefully you have enough on this page that you'll be set to go. The other page, same type things, only now A is not 1 when you skip the page, flip the page over here, okay? A is not 1. So I think I skipped right to number 9 here. Number 9, the only thing I can do is factor out a greatest common factor. I'm going to take a 2 out. I'm left with 9x squared minus 1. And now that's the difference of 2 squares. 3x plus 1 and 3x minus 1. Okay, so sometimes you have to factor a greatest common factor out. Number 12, you can't factor. Sometimes you'll get some that just, there's nothing in common. I can't take an x out. I can't take a 4 out. I can't take a 2 out. I'm done. They're not differences of 2 squares. 4 is, but 5's not. Okay? Number 14, if we look at 14, be careful here. Okay, this is a tough one. I have to think to myself, what multiplies to 18x squared and what multiplies to 14? Okay, I try 6x and 3x. And for 14, I'll try 7 and 2. I was lucky this time. I'm doing this because I'm almost running out of time. That gives me 12x and 21x, which gives me the negative 9. If this is negative, positive.